Okay, so we've looked a little at loops, but we're going to be using for loops a lot. So we want a little practice of taking a word problem and making it into a piece of code. So I've got a couple of examples here. Here are the two problems we want to code for. Sum all the even integers from 2 to 4. So the sum equals 2 plus 4 plus 6 all the way up to 44. The second one, a little more complicated, looks a lot more math-like. It's a summation. That's what a for loop actually is. It's a summation, right? So the for bracket up at the top, that's this piece here, the sigma, the starting point, the end point. Okay? The only thing in here is it doesn't tell us what the increments are unless we actually specified it in here. Okay? Now, the limit here is infinity. That's going to be hard to do even on a computer. So let's first start with this simple one. Sum all the integers from 2 to 44. Well, this is a start. This is the end, right? Okay, so we've got it basically set up here already, but we want to start from 2. We want to sum up to 44, and we want it to do for all the even integers, right? Plus equals 2 will do all the even integers, right? So if we start at 2, plus another 2 is 4, plus another 2 is 6. That'll give us all the even integers. Okay, and so this will be it. This should be the simple way of doing this. Let's see what we get. Okay, no error message from the simulator because we added the while. And now the sum is 506. Dare I suggest you try that on a calculator, see if it's correct. Okay, so that's fairly straightforward, easy to do. The questions will normally tell us the start, the limit, and the increment, and essentially the function, what goes in here in this problem. Let's go and look back at the second problem. Same sort of thing, right? Except what's inside, right, this 4 over n squared. So it'll be 4 over 1 squared plus 4 over 2 squared plus 4 over 9 squared. We could pull the 4 out if we wanted, but we'll leave it as is. And we're going to start at 1. The way math rates these things, if you don't specify otherwise, the increment is 1. But our trouble is going to be the fact that we want to go to infinity. That's not going to work for us. What we'd have to do is pick a reasonable number, let's say 100, and then maybe double it to 200 and see if we've converged to a number that agrees within 4 sig figs. So let's try that. Let's go up to the code. So we're going to go from 1, right? Not 0. 4 over 0 squared would be a disaster for us. We're going to go up to 100 here. And it's every term. And what we want is 4 divided by I squared, or 4 over I divided by I would be 4 over I squared, or if you're a little cautious about that, maybe you'd want to do this, right? And it's not an integer anymore. Sum can't be an integer, right? It's got to be a decimal number. So we have to do something like float sum is 0. But 4 is an integer, and I are in integers, and we've already seen that an integer divided by an integer returns an integer. So if it was like 4 over 10, it would be 0. So I'm going to make this 4.0, and when I print this out, it's a float, right? Right, so what I noticed is that my answer had to be a decimal, so I made sure sum was a decimal. I remembered about the dangers of dividing an integer by an integer, and as well, infinity I can't do, so I can have to go up. If I wanted to make it more like that summation, I could change this, the variable I, to the variable n. That's not necessary. N's just a dummy variable, right? So whether I used I or n, it wouldn't really matter at all. So I'm going to build this and see if I've made any mistakes. Okay, let's look at the simulator, the output. Okay, so the output is a decimal number, 6.5399. I'm going to double and see how close I get to that. Okay, so I'm going to increase the number of terms, and if this is a convergent series, I should get, the bigger I go, the more I should be reaching a particular number. So let me run that again. Go to the output. Okay, so so far it's only agreeing basically to 2 sig figs. So 200 terms wasn't enough. Let's try 400. Okay, let's look it out. This is looking better. We're to about 3. Stop that. Make this 800. Look at the output. Okay. Sort of going to 3. I'm going to go to 1600. See what I get. This is not exciting by any means. Right. We're almost at the 4th place. I'll do one more. Right. Right here. Right. But one thing we have to be careful about when we're doing this is floating point numbers only give you 6 or 7 sig figs. So it's possible that rounding errors can build up. So let's try it one last time before we call it quits. Okay, so it's not quite at 4. Good to at least 3 and a bit. But we're going to call it here. And when we quiz you, one of the basic quiz items will be, can you turn some mathematical equation into a summation for me? Take care. Bye-bye.